Today's lesson is on the subatomic structure of the atom. So let's look at our learning goals before we get started. By the end of this video, you should be able to do the following. You should be able to describe the characteristics of protons, neutrons, and electrons. And you should be able to identify how many protons, neutrons, and electrons there are in an element if I give you some information off the periodic table. So first off, every atom contains 3 subatomic particles. So you can fill these in: protons, electrons, and neutrons. The 3 subatomic particles are located in different spots in the atom. So protons are actually located in the nucleus. They have a charge of +1 and a mass of 1. Electrons are in energy shells around the nucleus, kind of like planets orbiting around the sun. They have a -1 charge, and their mass is 1/2000th of a proton. So basically their mass is very, 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 very small. Neutrons are also located in the nucleus, just like protons, but they have a 0 charge. They have no charge, but their mass is about the same as a proton. So there are some characteristics of protons, neutrons, and electrons that you need to know about. An atom overall has no electric charge. This means that the number of positive charges has to equal the number of negative charges. So in an atom, your number of protons always has to equal the number of electrons. When we represent atoms, each element is represented by a chemical symbol consisting of either a single letter that is always capitalized or 2 letters and only the first letter is capitalized. So I'm going to show you some examples of that. So obviously we've taken a look really quickly at the periodic table so far, but basically some examples would be oxygen is a capital O, nitrogen is a capital N, but something like neon is capital N with a lowercase e, okay? So there are some examples of how we represent atoms using symbols. The atomic number of an atom, this is important. Each type of atom has a unique number of protons. This means that the number of protons is what determines the type of atom that it is. We call the number of protons in an atom the atomic number. The atomic number for each element is always written in the upper left-hand corner of your periodic table. So that means when you're looking at an element, let's say we're looking at carbon with C, the number that's written up in this corner that I'm shading in, that is the atomic number. Okay? For carbon, your atomic number, I'll actually fill that one in for you if you want to put that as an example. So if you have carbon, you'll see the number 6 up in that corner. Okay, that's the atomic number for carbon. It also means it has 6 protons because the number of protons equals the atomic number. So there's hydrogen there. Its atomic number is 1. And this means that hydrogen has 1 proton. Okay. All right, next slide. Since an atom has the same number of protons and electrons, the atomic number also tells us the number of electrons. So an atom of hydrogen, if it has 1 proton, it also has 1 electron, because remember, protons has to equal electrons. The number of protons always equals the number of electrons. So how many protons are there in a sodium atom? So if you look up sodium on your periodic table, at the back of your textbook or in the sheet that I give you, you see the atomic number of sodium in the top corner, and it's 11. How many electrons are there in the zinc atom? So find zinc. It's sort of in the middle of your periodic table. See if you can find it. If you can find the atomic number of zinc, again, remember, it's going to be, you're looking for Zn, and you're looking for the number in the top corner. That's your atomic number, which is also your number of protons, which is also your number of electrons. So if you can find zinc, you'll see it's got 30 in that top corner, which means it has 30 electrons. Which atom contains 104 protons? Can you find that? Rutherfordium. And where do you think this element got its name? A scientist named Ernest Rutherford. We're going to learn more about him and how he looked at the structure of the atom later on. Okay, let's finish up some notes here. The mass number of an atom. The nucleus of an atom, we already said, contains your protons and neutrons. Okay, that is almost all of the atom's mass. This means that the mass of an atom is determined by the number of protons and neutrons in the nucleus. We don't consider electrons because remember the mass of an electron was very, very small. So we don't really take it into account when we do this. So the atom's mass number is the sum of the protons and neutrons. So protons plus neutrons equals the mass. So, I guess we're writing that here. So mass number is protons plus number of neutrons. That's very important. The mass number is always written below the element's name on the periodic table. So there it is right there. The mass number of beryllium is 9.01. We're for now going to round it to number 9. Okay, so always round to the nearest whole number. So if it's 4.99, you would round that up to 5. Okay, so if we look at beryllium, we know that its atomic number is 4. So this means that the number of protons is also 4, and the number of electrons is 4. Can you figure out how many neutrons it has? Remember, the mass number, which is this down here, look up at the top of your slide, the mass number is the number of protons plus the number of neutrons. So if my mass number, I'll write this in red, is 9, that has to equal the number of protons, which is 4, plus the number of neutrons. So if you rearrange this equation, you know that the number of neutrons is therefore 5. So beryllium has 4 protons and 5 neutrons in its nucleus, and it's got 4 electrons floating around outside of it. So what is the mass number of sulfur? If you look at that, I think on your periodic table it's 32.1, so we ran that down to 32. What element has a mass number of 39? Potassium does. All right, so the mass number can be used to determine the number of neutrons. I just showed you that. The number of neutrons can be determined by rearranging the equation mass number equals number of protons plus number of neutrons. So we can write number of neutrons as the mass number minus the protons, or the mass number minus the atomic number. So basically take the bigger number off the periodic table and subtract the smaller number. So how many neutrons are in a beryllium atom? If you find beryllium on your periodic table, this is the one that we just did. Beryllium has an atomic number of 4 and a mass number of 9.01. So 9 minus 4 is 5. How many neutrons are in a calcium atom? Well, if you find calcium on the periodic table, calcium's atomic number is 20. And its mass number is 40.08 or 40.1. So we're going to do 40 minus 20 is 20. So there are 20 neutrons in a calcium atom. All right, standard atomic notation, last sort of thing we've got to learn, I think, for today. The standard atomic notation summarizes the atomic number and the mass number of an element. So the standard atomic notation for helium looks like this. It's got the symbol He, it's got the mass number up top and the atomic number on the bottom, and that is always written before the letters. So we don't write it like this. Okay, we write these numbers here in front of the letters for the symbol for the element. So that's your standard atomic notation. You will be asked to write the standard atomic notation for each of the first 20 elements. So let's see if you can do this now. Write the standard atomic notation for each of the following elements. So pause the video right now if you can, and when you think you have the answers, unpause it and we'll take up the answers together. So nitrogen, if you look on your periodic table for nitrogen, it's got 7 here and 14 on the bottom. So 7 is the atomic number and 14 is the mass number. So my standard atomic notation has to have the mass number on top and the atomic number on the bottom. For calcium, same thing. You write the symbol, you write the mass on the top, and the atomic number on the bottom. And then again for copper, same thing. When you look on your periodic table, the mass of copper is 63.54, so we'll call that 64. And your atomic number is 29. So you should be able to do that, and we're going to practice it more in class. Oh, sorry, there, look, I have the answers. Didn't even have to write them down. There we go. All right, isotopes. Sorry, this is the last topic. So isotopes are two or more forms of the same element. So if it's the same element, isotopes must have the same number of protons, but they can have different numbers of neutrons. So for example, state the number of neutrons in each of the following uranium isotopes. So U-235, U is the symbol, so I know it's uranium. The 235, that's your mass. That's your mass and number. So that's how we write isotopes down. So in this case, if it's 235, it has 92 protons. I got that straight from the periodic table. And now to find the number of neutrons, I do 235 minus 92. That gives me 143 neutrons. A different isotope of uranium, U-238, still has 92 protons. That's never going to change. But it has more neutrons. It actually has 146 neutrons. Okay, so your definition of an isotope, different number of neutrons, but it has to have the same number of protons. What would happen if I change the number of protons? Well, if I change the number of protons, I end up changing the element completely. So instead of uranium, if I had 93 protons, I don't have uranium anymore. If you look on your periodic table, now I have neptunium. So here are some practice questions, and I'm going to give you another sheet like this in class. So when you get to class, we'll be doing this pretty much first thing. Can you fill in this sheet? I'm not going to throw the answers up now. We're going to do them as a class together. Well, maybe we'll do the first one on this video. So if I give you aluminum, what's the atomic number of aluminum? The mass number, the standard atomic notation, the number of protons, number of electrons, and number of neutrons. So you should be able to find on your periodic table, aluminum, its atomic number is 13, and the mass number is 27. So I take those two numbers and I put them with the symbol of the element to make my standard atomic notation. I know that the atomic number also equals the number of protons, so I have 13 protons. And the atomic number, because my number of protons has to equal my number of electrons, I also have 13 electrons. Now to find the neutrons, I've got to subtract 27 minus 13, and I get 14. So see if you can figure out the other two based on the information that I've given you. We'll take those answers up in class, and we'll do a whole bunch more.